Alright, this is part 6, the last part of the parametric truss tutorial. We just finished offsetting curves by area, and we're going to do a very similar kind of setup to go through this last part. The goal here is to create an attractor point which drives aperture size, offset distance, based on distance to that attractor point. So we'll be able to change the position of a point on this surface, and then all of the components close to that point will have either a small or a large offset, whatever we tell it to do. So very similar to the last one. Let's start just by copying that last function we made, and we'll delete the background and change the name. So let's call this one offset curves by distance to attractor point. All right, so we'll need a few things here. That one thing that we don't have yet, and that's the base surface. So all along we've been working with the set of planar surfaces, not planar, excuse me, the subsurfaces that we generated way up here in the first function. To get that UV point over the whole surface, we need the original lofted surface. So I'm going to just make another set of clients and servers here by copying and pasting. I'm going to rename this base surface server and client base surface, and this wants to be the loft. Okay, so now I'll take that, and that's going to be one of our inputs, and I'll just make a little room for myself to work here. This base surface, let's just turn it on. It's this, it's the lofted surface underneath. We're going to evaluate this. So surface analysis, evaluate surface will give us a point on this surface as well as a normal vector and a perpendicular frame, excuse me, a tangential frame on that surface. In this case, all we're interested in is the point. So there's our surface. We're going to have to reparameterize this. Let's look at it without that, and I'll show you what that means. And the UV point we need is, we're going to use a multi-dimensional slider. It's just a 2D slider. It lets you set two numbers. That's going to be our input there. So I'll select this, and you see there's our little point way down there at the bottom. And when I adjust this slider, almost nothing happens. That's because it's, this is evaluating this domain between 0 and 1, and our surface's domain is much larger than that. So to bring that down to 0 and 1, you simply right click the S input and select reparameterize. And now if we look, it might be a little tough to see, but now that green point kind of follows all over the surface, and you can examine exactly where those kind of UV coordinates lie. 0, 0, in this case is this corner of the surface. 1, 1 will be the opposite corner across the diagonal, etc. So there's our attractor point. You'll remember from our area calculation that we ended up with all these centroids, right? All of those center points for the planar faces. The idea here will be to measure the distance between our attractor point and all of these centroid points, and to create a set of values very similar to the areas, just a range of numbers. There's going to be a max and a min, and we're going to do the same remapping operation. So again, let's just make some room to cram this in here. And maybe I'll try and shrink this down just a little bit. We're going to need a distance node. That's out of the vector tab point section, distance between 2 points. We're measuring between one single point, our UV point, and a list of points, our centroids. This will generate a list of data. And again, we don't, I suppose we know about how big this is if we know how large our surface is, but we don't really know these numbers ahead of time. So this is another perfect example or a perfect application for our remap technique. So let's do that. In this case, the values we want to remap are the distances, and the only thing we have to change is the bounds. We're going to overwrite those numeric bounds, and everything already should be working, right? We've got a point, measure distances, and now we're creating a big list of numbers between our min and max. So let's just tighten this up just a little bit, and let's test it. I'm going to hide everything in the function, including the input surface. And we already know how to test this by just overriding the server. And it looks like it's working. So now as I adjust this 2D slider, you'll see that our offset distances are ranging from a very small number to the kind of max number here over at this corner. And as I move that point around, you see that kind of gradient range following suit. So I wanted to do another one of these, the kind of visualization. Hopefully you can follow the last example and create a map of distance. This technique will work for any list of data that you want to visualize with geometry. I hope all the fuss about the functions, the servers, and the client kind of makes sense at this point. I think we've got a really powerful definition going that lets us explore a very, very large set of design spaces and have very fine-tuned control over the geometry we're generating here in Grasshopper. That's it. Please post any comments, any one of the 6 parts, any questions in the comments section, and we will go through any questions next time in class.